not all farmers have adopted this technique, even if their farm field would be suitable for it. And so I wanted to understand the drivers and the barriers for such adaptation decisions. So if we understand why, and if we are able to simulate when farmers would dig such farming terraces, then we can include adaptation dynamics in drought risk models. So today I will present to you how I use agent-based modeling techniques to integrate human adaptive behavior in agricultural drought risk assessments. If we talk about drought risk, we talk about three factors. Three factors: hazard, exposure, and vulnerability. Humans have an effect on each of these factors. So whether they adopt rainfed production systems or whether they apply irrigation, that will influence the water source of importance when talking about droughts and hydrometeorological deficits. So the human footprint on the landscape that affect exposure. Farmers make crop choices and thus influence what crops are exposed to such potential hydrometeorological deficits. Also, socioeconomic, environmental, and other factors influence human sensitivity to droughts and their capacity to cope with such hydrometeorological deficits. So humans influence this hazard, exposure, and vulnerability, the risk system, but of course the risk system influences humans as well. Hydrometeorological extreme events can cause harmful impacts on different sectors, such as reduced crop production. And this will influence or instigate human adaptation decisions. Both their willingness and their ability to adapt will change. And that in turn will of course alter the likelihoods of an extreme event to happen or the impact of such extreme event. So clearly this human and this hydrological system are intertwined. And in my research, I adopt the socio-hydrological perspective and I model both systems in an endogenous way. So basically what I try to do is I try to simulate drought risk over time. Many existing models, they consider climate change, they consider population growth, but they ignore adaptation dynamics. And therefore they project drought risk to be increasing over time. Other models, they assume that the human system is perfectly economic rational, with people acting like Homo economicus and weighing costs of adaptation actions with benefits of risk reduction. And therefore they project that the risk will stay low. What we actually observe is something in between, and that is what we can label bounded rational behavior. It's influenced by the manifestation of risks, drought impact, and also by a variety of barriers that refrain people from taking an economic rational decisions. So my research in my PhD aims to model this bounded rational behavior using agent-based modeling techniques, and thereby is trying to contribute to the improvement of drought risk assessments and drought risk models. To conceptualize this inclusion of bounded rational behavior in drought risk assessment, I created a framework for agent-based socio-hydrological drought risk models. Starting from these static risk factors, I had a dynamic adaptation layer showing the influence of adaptation on these three factors. And then I stack another layer introducing heterogeneity of such adaptation, postulating that the level of adaptation is actually heterogeneous in space and over time, and emerges as a product of different actors. These actors behave individually, they are in different ways influenced by their network, by their ability, by their perceptions, and this results in an emergence of adaptation measures. The framework also represents this two-way feedback between potential impacts and adaptive behavior, which I discussed before, and that is visible through the red arrow on the left. So this is a conceptual framework, but before creating an agent-based model following this framework, one needs to understand the human behavior of agents of interest in a more detail. So why do people make decisions? Why did you make a decision last time you went to the shop to decide whether or not to buy something? How does the decision process take place? I looked into literature on bounded rational behavior, and there exist multiple socio-cognitive psychological theories. Two of them in particular attracted my attention. Protection motivation theory, which postulates that the intention to adapt is influenced by people's threat appraisal, their perceived frequency and severity of the events, and by people's coping appraisal, their self-efficacy, and also the response costs and efficacy. On the other hand, we have the theory of planned behavior, And they hypothesize that behavioral beliefs, normative beliefs, and also control beliefs drive the intention to adapt. So these two theories, they differ in the sense that the protection motivation theory places a lot of focus on threat appears that can be linked to risk perception, while the theory of planned behavior introduces a nice, interesting factor, namely the social network. There is also an important similarity, namely the control beliefs, the self-efficacy. These factors, they all point out to the ability, the self-control of people making decisions. So two theories, and the next step was then to find evidence from the field to support or disprove or complement these theories. What I did is I sought the opinion of African disaster risk managers, and I interviewed Kenyan national and local key informants. I also sat together with Kenyan scientists from a university close to my study area, and I surveyed 260 farm households using a semi-structured questionnaire. Based on the information from the key informant interviews, I mapped the drought risk system in Kitui in Kenya. Clearly, and of course, not surprisingly, the system is quite complex. However, I was able to find some patterns in this fuzzy cognitive map, and I identified 6 key factors that seem to influence drought risk, and that therefore should definitely not be ignored when we create a model representing this adaptation decision. First of all, we have household knowledge on risk and on adaptation, and also the self-efficacy, this factor that was also visible in the two theories. Then we also have response efficiency, the efficiency of the adaptation measures that was highlighted. And besides, farm attitudes toward change and risk perception prove relevant factors. Finally, also social network has a clear imprint on this map, proving the influence on the risk system. The African drought disaster managers, they agree with this in the sense that according to their experience, most measures are taken after drought events, so when the risk perception is generally quite high, or after having a training, and thus when this knowledge barrier is alleviated. The farm households themselves, they place risk perception as a runner-up, and they cite yield gains, the potential positive beneficial effects of measures, as their main concern, when they decide whether or not to adopt a new adaptation measure. So triangulating all this information from diverse sources allowed me to create a first design of behavioral rules, the parameterization of the agent-based model. I could also go one step further. So I was able to find statistic relations between farm household characteristics and their adoption behavior. Applying these logistic regression techniques, I found that, for example, the odds ratio, the likelihood of having adopted a measure in the past, is higher for farmers who believe in their own capacity, who are able to perform a cost-benefits analysis, and who were beneficiary of extension services in the past. Clearly, these factors point to human and financial capacity that influences adaptation behavior. Moreover, I found that the odds ratio is lower for farm households who experience more droughts and perceive the future to be more water scarce. We could see these factors that are linked to risk perception as barriers for adaptation, but they might as well also prove that the adaptation measures that are taken in the past in my study area have had a positive effect on the drought risk. So indeed, such statistic analysis cannot really distinguish between causes and consequences of the behavior. And therefore, in the agent-based model, what I did is I tried to combine the theories with some empirics to describe the decision-making process. And I used these kind of quantifications as seen on the slide to calibrate it, not just to describe the process. So this is the model that I created. It's called ADOPT. The agent-based model is designed as follows. The agents are farm households. So I have only one type of agents, and they all follow some kind of similar behavioral rules. However, they differ greatly in farm household characteristics, which are stochastically defined based on the survey datasets. ADOPT uses the crop water model, AquaCrop, to simulate yields on a farm scale. So there is fixed soil and crop characteristics, there is daily weather conditions based on the CHIRPS dataset, and there is the farm water management, which is specific to the farm being evaluated. Then maize yields, they drive households' farm income. And that will directly affect households' assets. This last factor then I use to derive some risk indicators. Adopt calculates whether households are in poverty, whether they suffer from food insecurity or require food aid. Farm income also influences the household behavior, their risk appraisal, and their self-efficacy. These factors, together with the cost and efficacy of the potential adaptation measures, they define the adaptation intention of the farmers. This is modeled as the likelihood of a farm household to adopt a new measure this year. Then on an annual basis, Adopt tracks these adaptation decisions of all the households in the model and updates the farm water management of those that really adopted a new measure. Therefore, Adopt is able to explicitly simulate adaptation dynamics and their two-way feedback with the drought risk. And the model monitors the evaluation of both over time. In a historical application of the Adopt model, I simulate the emergence of 4 different adaptation measures: mulching, which you can see on the top left, mechanized wells, drip irrigation on the bottom right, and Fanya terraces. I compare the complex bounded rational behavior that I explained before with 2 other scenarios. A business as usual scenario, where it is assumed that no new adaptation measures are taken. So we can see this as a baseline scenario. And also an economic rational scenario, where we assume that adaptation decisions follow the expected utility theory. So supposing that all households have perfect knowledge on risk, on adaptation, and that they are capable of weighing cost of investments with anticipated yield gains. What we can see is that the bounded rational scenario produces a gradual adoption of adaptation measures, showing innovation diffusion and the existence of barriers, while the economic rational scenario shows steep increases of the adoption of very economic efficient measures. Also, the sensitivity of this bounded rational scenario is evaluated, and that we do that using different initializations of the agent set and also by varying the weights of the different factors in our theory, in our agent decision module. So this probabilization of the model setup is visualized in the green shaded area on the graphs in the slide. The adoption of new adaptation measures influences the average and median maize harvests of households over time. So in the graph on the slide, you can see that maize yield varies over time, and drought years are indicated by vertical orange bars. They are calculated as a SPEI value in the crop season of below -1. And not surprisingly, we see that the crop yields in the economic rational scenario are quite high, even higher than observed. Using point data from my and from other surveys and information from gray literature, we were able to verify that the modeled yields, the mean and the standard deviation of the bounded rational scenario, is within a plausible range. Adopt also evaluates food security status of all its households, which is a result of having no food available on the local market or having no financial access to this market by the individual households. Again, using gray literature, we could verify that the modeled food insecurity levels of the bounded rational scenario, especially during droughts, falls within a plausible range. Then, Adopt is also capable of calculating food aid needs. Food aid is the amount of calories translated to US dollar using variable market prices that are needed to give all households in the model that are in food shortage the required calories to achieve food security. So this food deficit can be calculated in 2 ways. First, as I explained before and shown in the graph on the previous slide, we can calculate this on an individual household level using this agent-based approach where we include heterogeneity in household assets, then have food availability on the market, but also individual access to this market, financial access. What we also could do is by simply just calculating how much is produced in our study area and how much is needed. And then seeing this difference as the food deficits. In that case, we assume that there is a homogeneous distribution of the food, which is of course a mere presumption. However, if we didn't apply this agent-based modeling approach, this would be our best guess, our best estimate. We can see that the differences are quite large, with the homogeneous approach clearly underestimating the food aid needs. And so this shows the added value of using an agent-based modeling approach, accounting for individual situations when we evaluate drought risk. So, since ADOPT proved able to simulate past adaptation dynamics, we want to investigate how policy actions might alter the system in the future. In governmental policy documents, we found that 4 recommended actions to increase adaptation by farmers. We found additional and tailored extension services, improved early warning systems, ex-ante cash transfers when a drought is predicted, and reduced credit interest rates for adaptation actions. So by designing and by executing a discrete choice experiment, we were able to evaluate the effect of these actions on the intention to adapt by these farm households we surveyed. Using mixed logit regression techniques, we found that each of the 4 governmental policies, these actions on average, increase the intention to adopt new measures by the farm households, with better early warning systems promising the greatest impact. However, as we discussed earlier, adaptive behavior is a heterogeneous issue. So evaluating which characteristics of farm households influence the effect of and preferences for actions, we see that people with different income levels respond differently to some of these actions. Richer households, for example, have less preference for ex-ante cash transfer, while they benefit more from extension services. Educational differences also influences the effect of the policy actions on farmers' intention, especially early warning systems and credit schemes. More educated farmers, more educated farm households, they know how to leverage these actions and how to use them to increase their level of adaptation. Also, being a member of a farm group has an influence. It actually reduces the effect of all 4 of the government actions. And that is probably because a different version of the same kind of action is actually often present in such farm groups. So by adding the government as an actor to our agent-based model ADOPT, I can simulate these 4 actions in a process-based way. For example, ADOPT adds more knowledge to the agents if they followed extension training, or it increases their assets if they receive cash transfer in the face of an upcoming drought. And indeed, in the model results, they show that the government measures lead to an increase in adoption of adaptation measures, showing that the barriers for adoption were modeled correctly. Then, using a scenario approach, I explored a combined effect of these governmental actions. Combination of actions in the form of a proactive government investing in early warning systems and ex-ante cash transfers, or a strategic government investing in all 4 actions has an even more favorable effect on the adoption of drought adaptation measures over time. Again, also the effect of this on the emergence of the effects of the emergence of adaptation measures on crop yields is simulated. What we can see is that this reactive government adversely affects crop yields over time. This results in multiple food insecurity situations and high aid needs during droughts. A proactive government, however, can succeed in creating higher average yields and thus reduces the need for help and increases the wealth of the households. A strategic government initially has no influence on household assets as multiple adaptation investments are made. However, after a number of years, we can see these investment costs are paid back by the higher yields. And then poverty and the need for food aid, they drop drastically, which is clearly visible in the graph on the bottom right. So this analysis that I did was based on the assumption that there is no climate change in the future. And this is something I'm working on now. I'm testing what would happen if we have a drier, a wetter, or a warmer climate. And if that there is a robustness of government actions under these various climate opportunities. So I hope to be able to present these results soon, but I'm still working on them. For now, to summarize, the ADOPT model thus simulates in a process-based manner adaptation decisions of individual households based on both theory and empirics. And it internalizes the crop water model AgriCrop to simulate yields on a farm scale and is able to evaluate the heterogeneity within and the dynamics of drought risk over time. The agent-based model that I created can help to evaluate policy actions or the potential effect of newly introduced adaptation measures, and can thus support decision-making to achieve the Zero Hunger Sustainable Development Goal. So I want to gratefully acknowledge the large efforts of my colleagues Mike from UCSB, Moses from SECO, and Ralph, Ted, Anne, and Jeroen from the Vrije Universiteit in the design of the ADOPT model, in the data collection, to calibrate it, and in exploring its potential applications. And I want to thank all of you for listening to my presentation. I hope you find it interesting, and I'm very much looking forward for questions and a discussion. Thank you very much.
Thank you, Marthe. Other people can't clap, so I'll clap. This is really, really interesting. There's so much in here to dig into. I'm just wondering whether we can try to solicit some questions from the people assembled for the webinar. I have various questions of my own, but I'd first like to hear from others if people want to enter a question into into the Q&A or into the chat. Let's see if anybody does so. There's a delay. I can start asking you a few questions.
Sure.
So yeah, the first question I had for you was about the social methods that you used, the semi-structured interviews that you mentioned. So what did that look like? What sorts of things did you ask people, and how did you manage to secure goodwill amongst your participants in your study?
Well, thank you. Thank you for this question. It's well, I have a good collaboration with the local university. So they, of course, in Kitui, in my study area, they speak Ikamba, a language that I'm not familiar with. So I needed translators, and I had some very experienced translators who definitely helped with the goodwill of the people. And sadly, it's not an ethical thing to pay people to answer your questions. So I really had to rely on their, well, openness and their availability in time to answer. But it actually worked pretty well. People are very happy to speak about the issue, and that is also probably because, well, it is a pressing issue there. Drought, risk, water scarcity are really important issues, and well, they hope by providing information that we can actually design something to alleviate this. So I asked plenty of questions, let's say like that, and many of them were based on a Likert scale, so a scale between 1 and 5 or 1 and 7. To see many of these perception questions, you cannot just ask what is your risk perception, and you have to find proxies for that, and then have multiple actually questions asking about the same proxy, and then you can average these and then, well, make your own indicator from it. There has been multiple studies, or at least a few, that also have questionnaires done for similar studies. And I based my questions also on their research. Also, I think I was very grateful to be able to go to the field multiple times. So in the first time that I went there, I didn't ask any questions. I just was there to listen what they have to say. And that also helped me to feel what are the more important things to ask, and that helped me designing the questions. So I think that's also, well, I think that helped strengthening the survey and then also piloting the questions.
That's great, Marthe. There's a follow-up question from Roger Few from UEA. I'm gonna just allow him to talk to ask the question directly. Go ahead, Roger.
Hi, can you hear me?
Yes.
Yeah, well, I think you've pretty much covered it. I was trying to get a sense of the type of questions that you'd be asking, particularly at the grassroots level. And you said they were generally questions with multiple potential answers that would then be coded on a Likert scale.
Yes.
Was that the bulk of the questions like that, would you say?
Well, of course, you have the basic set of let's say, socioeconomic characteristics, because you want to know their socioeconomic livelihood situation. Mm-hmm. Then I also asked them like quite open questions of what is the problem, what is the main problem, some questions in ranking importance, so pick the 3 most important issues. But then many of the questions related to perceptions, to the for example, the protection motivation theory or theory of planned behavior factors. well, there you have to use these proxies and this Likert scale to be able to quantify them in some way. I also directly asked them, so what does influence your decision? Also direct questions on what would influence their behavior were asked. Yeah, more like sometimes it's kind of the same question or a different question for the same answer as a check that I'm really asking the right processes and identifying the right factors.
Okay, but in order to then convert that into data for the model, am I right? You then have to convert all those into some kind of binary, either this or either that. I'm a qualitative researcher and trying to sort of get my head around quite how you folks do this.
Well, so that is also why I didn't use this the statistic regression analysis that I did. I didn't use that exactly as an input, directly an input to the model, because of course some of the questions were super interesting, super important for the processes, but you cannot really quantify them. So then in the model, I added these processes in a process-based way. For example, like how I know how many people are in their network, and I know the rate of how their network influences them, and then I have to, sometimes you have to describe this process in the model without having just a direct, okay, 10 people means so much more influence, 5 people means so much more influence. We cannot quantify such things, and then you just process it in a model it in a process-based way. If that answers your question.
Yeah, I probably need to do a bit more background understanding of quite, but thank you. Yeah, it's taken me a large way to understand. Thank you.
Thank you, Roger. So there's another question from Chris Priest from Bristol. He's saying that ABMs are notoriously difficult to parameterize. And as a result, they most often yield results which are correct qualitatively, but very approximate quantitatively. Would you say this is true of your results, or do you feel you found a way to parameterize them effectively?
Yeah, well, that's definitely the question, let's say. It is very, very hard to find validation data for agent-based models because by definition, you model individual processes, and most data sets, they are an aggregate, an average. Even if you just talk about yield data, you find yield series over time, but they're an average, an aggregate of both big farms, small farms, and medium farms in the same area. And we want to understand only the process of these small farms. So this is definitely quite difficult. And that is why, well, I really focused on and also use these theories. So we know these theories are, well, they are existing theories proven to really describe the processes. So I'm not reinventing the wheel there. And I tried to model them based on what I found in the survey data set. So using the right proxies for each of these factors in the theory. And so in that sense, you can parameterize based on your survey data set. So which factors are important, which of these important factors, how can we link them to the factors of the theory? And then of course, you can validate at some point. In my case, it was more like a point validation. I had a few years of information of average yield, of poverty levels. So I could at least see if the range is correct, if the variability is correct. And by no means I'm going to say that the monetary value that I estimate for 8 NEET is the exact that is going to be there, because I cannot validate such information. But at least it shows you, I think such agent-based model as I made can do what it is made for, namely evaluate the effect of measures. Do they work well? Do they not work well? Because we could see that we have the right drivers, we have the right barriers in there, and that's the main importance of it. I wouldn't use it to predict how much money the local government need to have ready. Maybe an approximation, but not like an exact amount. And I also don't think, well, my model is also not made for that. That's not the goal.
Okay, great. And I think Jeroen Ertz has posted something in the chat to kind of further explain. He said, on the calibration, indeed, it's a challenging subject, but this is why we use theories as a basis and then apply the theories to the surveys to find empirical data to parameterize the model note also that the behavioral theories are based on empirical data. The challenge is the validation of ABMs. So there was another question. Chris Hubbard from the WRI in Cardiff said, great talk, thank you. What interaction and response have you had from any local non-academic stakeholders on your approach and your results? And how do you think the ABM can play a positive role in decision-making while communicating any inherent assumptions or limitations of that method?
Yeah, thank you for that question. I think a very important first step is, and that is what I said before, first going to the community. And what I did is I went here and I said, I want to create a model to simulate drought risk in this region. What do I need? And so by really starting from a very open, almost bottom-up way of saying, okay, what should be in a model? And then also asking many different stakeholders. So NGOs, farmers themselves, example farmers, scientists, any different or local governments, national governments, agricultural organizations, like totally different people, like what should be in the model. That also allows people to put more trust in what is then actually modeled. And I must say that I had the opportunity to present this model results to some Kenyan scientists, but not to Kenyan policymakers yet. I mean, this is definitely on the list to do in the last year of my PhD. But I would love to explore with policymakers how we can, well, use this as a real tool for them to see if they can use it and how they would like to use it, if they trust it. I've tried to stay close to their policies. So for example, I didn't invent policies myself, but I looked in the policies they are interested in to include. I asked them if that were really the ones to include. But I think this interaction throughout the full process is important. And then also to achieve this final step of well, adoption or use by local stakeholders.
Okay, thanks. We have another question from Hosea Congador. Thanks for the good work. Why did you settle on maize yield and not other crops like cassava, sweet potatoes, or pigeon peas, or even mangoes? Can the model incorporate more than one crop?
Yeah, so it definitely could, because AquaCrop, like the FAO model, has well, is capable of doing so. So you just have to parameterize the AquaCrop model to have another crop. But since even for maize yield, having this AquaCrop model, parameterizing it to have the variety that is used there, having the correct all the characteristics of the maize crop is quite challenging, and it doesn't exist yet for these other crops. Maybe there's a few field trials, but then you need more field trials for all these other crops to make AquaCrop simulating the right variety of the crop, and then you could easily introduce it. So it actually was also on my list to do at one point, but I think given that I'm not an agronomic scientist, that it is for me personally too challenging to start doing this as well. Collaborating with people who want to calibrate AquaCrop, then it's super easy to implement it in the model.
Okay, great. Owen Jones from Cardiff said, thanks for the great talk, impressive work. What software did you use, or did you develop your own? Well,
that's an interesting question. I kind of use Python, R, and MATLAB, all three of them, because AquaCrop was simulated in the open source version of AquaCrop, and it is in MATLAB. And so I had a module. And then the behavior, I first started modeling in Python. Then I found some of the analysis was easier in R. So, I mean, it's more like the processes, and you can actually use any language for that, the language that you prefer the most. And then most importantly, the actual behavior, I started modeling them or it in NetLogo, a typical agent-based modeling tool. And I can also link R to NetLogo. If I would do it again, I would use one language, because of course that makes the model more smooth. That's, yeah, when building up a realization afterwards that I should, well, you can translate it to any language, I would say.
Okay, thanks. I was curious, you had something about the threat assessment that piqued my curiosity. So you mentioned that people who experience frequent droughts sort of lose hope or something like that. I mean, and then there was sort of a dichotomy that I recognized between people perhaps that were uneducated, that experienced multiple droughts and give up hope, versus others that are invested in, that continue to do better. I mean, could you see this stratification of society, of wealth inequality starting to grow based on your model simulation?
Yeah. I actually also did a cluster analysis, and there actually you could really see you get like a diverse group of larger farms, and then you had the educated richer farms and the non-educated poor farms, and that is just like an unsupervised cluster algorithm. So that's not me feeding in that this is existing categories, but it is the cluster analysis finding these differences. And I mean, I didn't show it here because it gets too complex, but you can do this. This discrete choice experiment that I showed, so the governmental actions and their effect, you can do that for the different clusters and then see how these different actions influence, let's say, the richer and more educated farms versus the less rich and less educated farms. You could definitely start evaluating this, and that's definitely also an interesting thing to do. About the losing hope, I think that's the slide where we did the logistic regression. And so, yeah, the thing with the logistic regression is either they have a low risk perception, so they didn't adopt measures, or it is because they already adopted measures that they have a lower. So there is this cause-consequence thing you don't know when you just do a purely statistic analysis. And that's why, well, as Jeroen also said, I think it's super important to base your whole model on an existing theory by experts in the field of socio-cognitive behavior, because, well, I became kind of a little bit of an expert on it, but I'm definitely not one of those experts that invents a theory.
Great. There's a question from Katerina Michaelides from Bristol. Thanks for the great talk, Marthe. In your study, you evaluated some key adaptation measures. Is it your sense that the same outcomes would hold for other drought adaptation strategies too? Are the results broadly transferable to other measures?
Yeah, I think in some sense the answer is yes. It of course depends on, well, three factors are very important. Of course, the costs of it, the benefits of it, and also how popular it is within the network, because that distributes knowledge about it, and knowledge can be a barrier. So if you introduce a new measure that is quite expensive, like for example, the mechanized wells, you could see adoption is really slow. While if we have a popular measure like the Vrije terraces that is already adopted quite often, then adoption rates will be more steep. Also, measure that is less adopted, so less popular, but super cheap and economic efficient, like the mulching, then you also see a steep increase. And so there is, you know, this trade-off, but you can find, I think for all the older measures that I didn't evaluate, they might fit in one of those four categories. And you could easily do this with different measures. You need to know their cost, their popularity, their and then the effect on the yields, because they have to be included in aquacrop. So we need to exactly know how they change the system. So for example, Vrije terraces, they change the curve number because you get a flatter area, and that, so you will have to change the curve number, and you will have barrier. So aquacrop needs to be able to know how to model this process in a hydrological and in an economic way.
Okay, thanks. Roger Few, again at UEA, has a question. Is the existence of correlation between factors in the model a methodological problem, such as correlation between self-efficacy and access to resources for adaptation?
Excuse me, can you repeat it?
Yeah, he's wondering whether there's an existence of correlation between factors in the model that makes the model not function well. So, for example, correlation between the self-efficacy and access to resources for adaptation.
Yeah, I think when you do this statistic analysis, then this causes a problem. If you have highly correlated variables, your model will perform, well, not in an optimal way, or not how you think it is performing. And that's also, again, a reason why I use these theories. So these theories, they already describe the links, and of course there are correlations, but that's how it is. And so we should also, in our agent-based model, describe this process how it is. even if it has correlation. So of course, people will not adopt if they don't have the money, but money will also influence their perception of the cost. It will influence their ability to do something. So we model these correlations in our agent-based model as is in reality.
So I a couple, because there seems to be a gap in the questions from the crowd, but I was wondering about the policies. Did you find that people at the household level were aware of climate adaptation policies and, you know, recognizing what impact they might have on their lives, or were they fairly, you know, naive about it or ignorant about it just because the information wasn't you know, disseminated about these policies?
Yeah, I think this problem didn't pose with the policies I used because all of them are already present, and it was more like improving them. Like they have early warning systems in some way, but of course they want to know it more in advance on a seasonal basis, and they don't have that, but they can imagine easily if instead of giving the weather forecast for a week, they get it for a season because their traditional rainmaker also knows it for the next season. So they know this. They get extension training. This is accessible, but they want more. They want improved ones. That's something we could ask in the first time we went there. They think it's not good enough. So if we would improve it, that's an easy thing to imagine. Same with access to credit markets. Most people know there exist credit markets, but they can't access it. So they can imagine themselves having access to it, let's say. Of course, it is an assumption. And of course, this is also something I checked. So I also asked if they have had access to credit markets, if they had extension trainings in the past to also, well, correct for this.
And if you knew that resources were limited from governments, what policies do you think would be the wisest to prioritize? It seemed like from your analysis, there were a couple that rose to the top, but what do you think is the most effective way to assist agricultural yield and resilience to drought shocks?
It really depends who you want to target because they're heterogeneous. So if you want to target the poorest ones, this ex-ante cash transfer, just giving them cash in advance so they can invest it in something, will really help a lot. If they are more educated and they can do cost-benefit analysis, then these credit schemes are super relevant because they know how to use them. They can really optimize the use. And then, I mean, it really depends on the target group. And that's also what came out of the results. So yeah, it's I don't think I can answer what I would suggest them. I would ask them which group they want to target first.
Just building on Chris Hubbard's earlier question, do you have any plans to go back to Kitui and to present your results once COVID allows people to travel?
The plan was there. I would have been there before. So let's see what COVID says. If COVID allows, definitely yes. I need to thank so many people there, and I mean, I want to show what I got. I want to discuss it and also suggest improvements. But let's see what COVID allows.
Yeah. There's another question from Roger Few. Presumably the livelihood impact of recurrent exposure to drought as a barrier to adaptive behavior varies greatly according to pre-assets. So qualitatively quite different in effect depending on wealth status. Do you agree with that point?
Yeah, what I think there's something I could track in my model that people with a higher asset at the start of the model, they are more soon able to invest in measures. If then a drought occurs, maize prices are high, they can sell their excess maize at a higher price, and so they gain even more money, while those who had to wait till year X or Y before they had enough assets to invest, well, they lost so much opportunities to gain from it. And so you can see some kind of poverty trap happening, which I think is also what is happening in reality. So it was a nice, well, finding that our model could also, or did also model this, simulate this.
It seemed like your model result about reactive government was quite striking as well, because especially governments with more limited resources tend to be reactive to situations that arise. And I know that even international organizations are largely focused on reacting to crises rather than actually coming up with long-term plans of resilience and investment. Do you have any comments about that?
Yeah, well, I think it's important to believe in your people, in the farmers, because if you give them the right tools, they can protect themselves as well, and then you're not more or less responsible to do all the after disaster happens things. And so I think it's really worth looking into this proactive approach, and that's also what the model shows. Of course, for scientists, this is not a surprise, that acting before really is an economic efficient way to deal with the situation. And so, well, of course, the model shows that, but I also think the model shows that if you give people the right tools, they can protect themselves. And then I think that's maybe a positive message as well.
Okay. One last question I have, and if other people have questions, please type them in now and let us know. Otherwise, we'll close the session. But I wanted to know whether you think, how representative do you think Kitui County is across the broader region of, drought-prone, Kenyan agricultural villages?
Yeah, I think my model is representative for semi-arid areas, so there is frequent droughts in a not very optimal maize production area. So Kitui is in one of those ASAL countries, arid, semi-arid lands with only a medium potential agricultural production. And so maize should be important because for me, maize is also a proxy for food security, which is of course a large assumption. I think if you would do this in the north of Ethiopia, you would take teff because that's the main crop there. But like the model structure would be applicable to many regions where agriculture, subsistence farming is the most important livelihood. I wouldn't be doing that blindly because I make a lot of assumptions about behavior, and I would feel very bad assuming other people, other cultures have the same type of behavior, have the same type of importance of factors influencing their decisions. I think now I take agronomists, maybe have some animals, but if you would do this for pastoralists, maybe their decisions are made based on totally different things, and I wouldn't feel comfortable just translating it, and you will have to prove it with field data that it works. Yeah. Say. But excellent model structure-wise, you can adjust it.
Great. Well, Marthe, this has been really stimulating, and I really thank you on behalf of the Water Research Institute at Cardiff University and everyone who attended today from various places. Thank you so much for enlightening us about this approach to, to drought risk. And yeah, we hopefully we'll have more opportunities to chat in the future about this sort of stuff.
Yes, well, thank you so much.
Thanks to you all for attending today. It's been really, really nice to have everybody.
Yes, thank you for the nice platform and to listen to my presentation. Thanks a lot.
You're welcome. Thanks a lot. Take care, everybody. Thanks.